So we have probability of compound events. Compound events. Now, do you guys remember the word compound from something else that we had in the past?
No.
Compound interest. Ba, ba, da, ba, ba, ba. Didn't that mean that it was related to something else? Remember? They did combine. Yep, and that's exactly what's happening at this one. Yes, sir. Didn't I talk about the study session in here? After school tomorrow, we're having a study session until the latest 4:30. So you guys can take the activity bus if you want to.
Is tomorrow Thursday?
Tomorrow is Thursday. We have a test Friday.
Oh. Mr. Smith?
Yes, ma'am.
I think I'll just take the test on Monday.
Okay. She's not going to be here. She's not deciding when she takes the test. She's not going to be Yes. All right, mutually exclusive. Include the formula. 2 or more events such that no 2 events can happen at the same time. So, for example, the probability of A or B equals the probability of A plus the probability of B. So, event 1, standing. Event 2, sitting. That would be mutually exclusive. You can't be doing both at the same time, right? No. If you're sitting, you're not squatting. If you're sitting, you're not squatting. If you're it's not squat. If you're sitting, you're not standing. If you're standing, you're not sitting. Is that clear? They're mutually exclusive. They are excluded from each other's situation. Then we have inclusive, when 2 or more can happen at the same time. Okay? So those are 2 events. Event A, singing. Event 2, sitting. Can you sing? Can you sing while sitting? Okay? Yeah, you can sing while sitting. Okay? So that would be a situation where 2 things can happen at the same time. Do you agree? Okay. Now, we're going to get into a more concrete example that you can see with this. Okay, make sure I'm recording before I get into the depth of the lesson. We are. It is. Thank you for asking. So here's our situation. We have aces and kings. We're talking about a regular 52 card deck of cards. Okay? Please focus with me though, okay? Aces and kings. Do you agree that if you have a card that's an ace, it cannot be a king? See this Venn diagram here where there's 2 different situations. We have one thing here, then we have another thing here. They cannot be part of the same thing. No luck? Oh no. Okay. Sorry. She's with us now. We're good. Here is ugly handwriting, but that's yesterday. There's what we started. Okay. Sorry. So we have aces and kings. You cannot have an ace that is a king. You can't have a king that is an ace. Those are 2 things that do not combine. So whenever we're looking at probability, I'm going to just make this connection right now. I didn't do this in the other classes. So the probability of having ace or king. Okay, that is going to be what? Is that inclusive or exclusive? It says right there. Okay, it's going to be exclusive. It's mutually exclusive. Now, I would ask myself, can I have both? And I would say no. That's the biggest thing about mutually exclusive. You would say no to, can you be both? Can you be a king and an ace? No. No, you cannot. Okay? No, you cannot. Then there's a situation like this. Can you have probability of hearts? I'm going to just do this. Or king. Looks like pork. Okay? Heart or king. Can those happen at the same time? Okay, yes. Take care, bud. Do you have internet access? Okay, you're definitely gonna want the last 4 questions on this video. Yeah. Yes, they can. You can have so I want you to do yes, like this, and write the word inclusive. Yes, there is a situation where you can have both a heart and a king, and it's this guy right here. It's the King of Hearts.
The King of Hearts.
Yes, that's right. Also known as Charlie Belibradic, the King of Hearts.
Yeah. And I'm the queen. Are you gonna like her? I mean, not like that. Like.
He So yes, it's inclusive. It is inclusive. Now let's talk about this. Let's talk about this situation here. Hearts and kings. Let's find out how we're going to see that there is one situation where you have the King of Hearts. You are going to, after we're done with this, actually, you know what? Take a couple of seconds, please. I want you to rewrite the formula on your notes. Good luck, bud. Pin them quick. Yes, you have to, because when we're doing an example, I don't want you flipping back and forth. You're putting it to the right of that. There's a big open area. I'm only giving you 30 seconds to do this because we got to get moving. Chances are slimming. I want to, hopefully. Look where it says example King of Hearts. Example Hearts and Kings, right to the right of that. Okay, it's about 45 seconds. So do we have at least the words, not the box?
No. No, I didn't. Get it?
Much better.
Popping his knees.
Drop and pop. Pop my knees. All right. So we're going to find out exactly how we would find the probability of having a king and heart. So hearts and kings together, there's only one King of Hearts. I'm right here reading.
There's only one?
Yeah, there's only one King of Hearts in a 52-card deck. So we... Why can't there be two?
Why do you ask every question? Because I like asking questions.
So here's the situation. You said it, not me. The situation is like this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hearts. And we have salud. And we have 1, 2, 3, 4 kings, right? So 13 plus 4 is how many? 17. But the trouble is, we just counted this guy twice. We accidentally counted him twice because there's 13 hearts and 4 kings. So in order to get it to be the correct number of actual probability, we would have to take how many hearts there are, 13, plus the amount of kings there are, 4, and we have to subtract one of the kings because it was counted twice, because they share that King of Hearts, so we don't want to count it twice. We only want to count it once. So here's a visual representation of that, and that's going to be the inclusive one. So we have, in our situation, hearts. Then we have plus the kings. But then we have to take care of one of the 2 kings. Okay? I did that last period too. Okay? So we had to take care of that. We wanted to reduce them. Now, I could do the numerical representation of this. We did that in a different class. I think it was 5th period. But I want to get through this so we can show all 4 examples for the YouTubes, because this will be the only class that we did all 4. Yeah? Was it? Did it clear up? Okay. Okay. Ooh, middle? Why did you guys both just chant that after he said the word middle?
What did he say?
You heard it, right?
No, I just heard make the wire. That's not.
Did you say it?
I heard.
Okay. That was strange. All right, speaking of strange, let's continue with this. What? Determine whether an event is mutually exclusive first. There's 2 parts to this. And then you are going to find the probability. So, first situation. I'm really going to zoom in here because I did not have enough room before. So, you're going to use all the space in your notes around this guy. Okay, so you probably won't be able to write as small as I do. All right, but you're going to want to use all the space that you have. So, an 8-sided die is tossed. There's 8 sides to it, okay? That's the situation. Okay? Keep in mind that this is not a situation where once we roll the die, we can't get that number again. Or once somebody gets a sucker, they can't win a sucker again, okay? There's nothing being changed away from the situation, all right? Okay. Here is our situation A. We have the probability of the number being even. And we have the probability of a number being less than 5. Here's our situation A. Here's our situation B. Yes, write as I write, how I write, if you have the room for it, because you're going to use all that stuff there. Okay. Johanna, do you want another piece of paper because of all the bleeding that went through? No, not blood. It was her marker. Okay. So we have those 2 situations. Now, the first question that you should ask yourself, can these 2 situations happen at the same time? Do they have anything in common? Yes. Question? What do you think? Yes. Look in your notes. What did you put where you have a yes? Where do you have a yes? In your notes, where did you put yes, Donnie? Inclusive. So is this one inclusive or exclusive? Inclusive, yes. So I'm going to put inclusive. Okay? Now we need to find the probability of these being even. I'm going to do it in a different color. The probability of those being even. What is the probability of rolling an even number when we toss an 8-sided die? Just to remind you from what we did last week. Probability. We have to say how many chances we have to get the desired amount over the total chances. How many numbers are there that are even on an 8-sided die? SS? 4, because we have the number 2, the number 4, the number 6, and the number 8. There are 4 of them. There are 4 out of 8 choices that will make that happen. And because Mr. Smith will give me half credit if I don't simplify and reduce, I made it into 1/2. Now, what's the probability of P being less than 5 when we roll it? Corey. 1/2, because there's 4 of them. We have less than 5 as 1, 2, 3, 4. There's 4 options. And see how I did that with my hand? Okay, that's exactly how I want you guys to do it. It's not like you're counting, adding 5 plus 2. Okay? If that works for some of you, that's fine. But this one, this is actually visually representing. You are simulating the situation with your hand when I was just counting that up, okay? You're simulating. Didn't we do simulations the other day? Yeah. Yes. Now, we have inclusive. Actually, I should say exclusive. That's how it usually was in the 2090s whenever there was somebody had a remix. Now we have to find, since it is inclusive, what I'm going to do is I'm going to verify that I'm doing this correct. I'm going to verify that I'm doing this correct. Okay, inclusive. I have my A, good, that was the evens. I found my situation B, that was less than 5. Now I need to find what we did last night, the probability of A and B. The probability of A and B. View, let's go back to 150. A and B. So I have a situation of the probability of even and less than 5. And because on the homework last night I remembered what we needed to do, what do we need to do with these two probabilities to find when those two are both in situations, Jace? Multiply them together. So I'm going to do 1/2 times 1/2. Now, those are common denominators. Do I have to have a common denominator when I'm multiplying fractions? No, you do not. You just multiply straight across, so I have 4.
Oh yeah, you said that yesterday.
Mm-hmm. Mm-hmm.
Girlfriend.
Mm-hmm.
He's a boy. That was like scary.
Now, we just found our situation.
That's like not looking in a closet.
All right, stick with me. Stick with me. Now, we just found, I'm gonna move this so you guys can see exactly what we're doing. Hey, ladies, gentlemen, stick with me. Okay, this is the point where people were very confused the last period, so I want to make sure that if they actually do watch this video, they can see where it's coming from. Now, I just moved that down. You do not have to write it again, okay? I just moved it down. But here's the situation. I'm going to highlight what we just found. We have our situation A, or our, we just found what the probability of event A is. Then we just found the probability of event B is. Then we found what the probability, I already did that color. The probability of A and B is. So I need to plug in what I highlighted green, what I highlighted blue, and what I highlighted yellow. And in order to do that, I'm going to take my, I'm going to use pink. So I'm going to plug everything in there. Here's my green, there's my green. So I have the probability of even or less than 5
Is this going on odd?
equals,
Is the pink going on odd? Or is this
the pink is going on odd.
B?
We're not on B, we're on A. We never stopped A.
Oh, that's not.
Just that's tiny. Ignore this for right now. Okay, that's not there. So I'm just doing this for visual clarity. Now, we have the probability of even or less than 5. I'm just rewriting what it has there. I have to plug in what is green. What is my probability of A? 1/2. I'm going to plug in what is highlighted blue, my probability of B. 1/2. Then I'm going to subtract, because this is a subtraction sign right here. Subtraction, 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 subtraction. That's a subtraction sign. It's a subtraction. Okay? I'm going to subtract the probability of A and B, which I already found, and it's yellow. What is it? 1/4. Now, to remember how to do certain things for the park test that's coming up, what do I have to do when I add or subtract fractions? What is it, Dana? I have to have common denominators. You are correct. I have to have a common denominator I have to have a common denominator in order to add or subtract fractions. Now, that one's pretty easy. I just have to make it 4. I just have to make it 4. Hopefully you guys will be able to see that, and I'm getting back. Batman. Okay. I just have to make it 4. So I have the probability. Once again, I'm just rewriting it. If you don't rewrite this one, if you have room to the right, that's cool. Even or less than 5 equals 2/4, because that's equivalent fractions to this 1/2 here. Do you guys want me to do it in a different color?
Yes.
This is bubblegum pink, silly. Okay, I'll do forest green. 2/4. Quiet. 2/4. 2/4, because these are just equivalent fractions of the exact same thing that's above it, minus 1/4. Now I have common denominators, so I just add the numerators or subtract it, whatever's going on there. So Lainey, what is it going to be? That is going to be 3/4. Because I have 2 plus 2 minus 1, which is 3. I'm going to circle this bad boy. Okay? That's as long as any of these are going to take you. Let's do one that's a little bit different that'll go faster. Question?
I'm just confused. I thought you add those
I'm sorry, can you repeat that question?
Okay, I thought you just add ones, a half and a half together, then those are into two.
Yeah, common denominator. Cool? All right, I'm going to back this up. Okay, good. Now the probability, this one's going to be easier because number 6, the probability of rolling a 6 or odd. Can those two happen at the same time? Can you have a 6 that's odd? No. So that one is exclusive because that's the word that you should associate with no is exclusive. Excluded. So I'm going to find the probability of 6. This is what we've been doing for weeks. What's the probability of rolling a 6 with an 8-sided die? Anybody? 1/8. Now, what's the probability of rolling an odd with an 8-sided die? Yeah. 1/2 because we have odd numbers. 1, 3, 5, 7. There's 4 of them. So we have 4 over 8. And you know what? I'm going to go ahead and do 1/2 here, but I think I might keep that 4/8. Since we are exclusive, since we have an exclusive track here, that's all we have to do. We only have to do the exclusive formula. The exclusive formula is super simple. Oh, we got it, yeah. The exclusive symbol, or the exclusive one is right here. All we have to do is just add a 4th to an 8th. So much nicer. So much nicer. So we're adding a 4th to an, sorry, I said a 4th to an 8th. We have to add a 1/2 to an 8th. So I'm going to change it up because I'm getting near my answer that I'm looking for. I'm going to zoom out a little bit too. Say, back off, Smith. Okay, we're going to go red. So I have the probability of 6 or odd equals the probability of A plus the probability of B, which equals 5/8. Which equals 5/8.
Oh, that's all we have to do?
Yep, those ones are so easy. Sorry, I'm just getting out of here so I can do... We're going to do C and D together. I'm going to guide you through both so that way people can hear it on the end of their notes in the video that I'm doing right now. Yes, sir. No, because since we're adding and subtracting fractions, I didn't want to reduce, only to bring it back up again. Because I did have it as a 1/2. I did have it as a 1/2 right here. Ooh. Here's my 1/2 right here, but I would have to bring that back up anyway, so I can see that my denominator is 8, and I'm like, ooh, I don't want to have to do more steps, right? But you can if you want to. That way you can avoid more issues. Okay? Yes, ma'am. It's exactly like the notes. Yep. You have to. Well, the first 4 of them, you just have to say exclusive or inclusive. Okay. I got to find one of my songs that starts with that. I know I've got 10s.
Wait, do we have to save or do we write it down?
Save? What?
Do we have to save or do we write it down?
You would write it down. I won't be there. It's like, you're doing your homework tonight? Ready? Watch a scary movie in there? Exclusive. Now, here we go. We have a situation. The first thing we need to ask ourselves is, we going to answer yes or no to this question. Here's the situation. Can we have the number 4 that is prime as well? No, 4 is not prime. So this one is going to be? It's going to be exclusive. Quiet. We got to get through this. So we have the probability of rolling a 4. We just did the probability of rolling a 6, and we know that it's 1/8. Then we have the probability of the prime number. 1 is not a prime number, so we just have 2, 3, 5, and 7. So how many was that? 4. And since it's exclusive, all I have to do is add the probability for, or prime. I have to add the probability 1/8 plus 4/8, and there's my not reducing again, but it's not the final answer, so you won't get marked off. And that one's going to be 5/8 once again. That's the exclusive one is easy.
The inclusive one is
So we're gonna do an inclusive one together right now. So here's the part where people who were in my class earlier today did not get this one.
we only have like 5 minutes.
Yep, we only have 5 minutes, but it'll work. Okay, quiet please. Hey, this is a hard one, so I need you sticking with me, please. Now, this is what we have to look at. We have 3 different, or 2 different situations here. We have an event A and an event B. Can you have a number that is greater than 4 and, or an 8? Will that be the same thing? Yeah. Yes. They have something in common, so right away we are inclusive. We are inclusive, okay? We are including those 2 together because 8 is greater than 4. So we have to find the probability of a number greater than 4. We have to find the probability of a number that is 8. We have to find the probability of greater than 4 and 8. Now, the way that I just laid that out, that's how I expect every single one of you guys to do your homework tonight. Okay? You know why? Because, well, there might be enough room for it, but the bottom line is, if you write like that, I'll be able to tell exactly where you went wrong, or more importantly, you might be able to discover where you went wrong when we're checking ourselves tomorrow. Yeah, because there should be no wreckage.
No records in this room.
So we have probability of it being greater than 4. What is it, Lainey? Please. So we have greater than 4. We have 5, 6, 7, 8. There's 4 of them. 4 over 8, which equals what? 1/2. Then we have the probability in 8. That's the 4th time of us doing it, is 1/8. Then we have the probability of greater than 4 and 8. This is reviewing what we've just been doing the last 20 minutes. 1/8 times 1/2 is going to be what?
1/16.
Thank you. 1/16. Now I have to plug those 3 numbers into our formula, which our formula of an inclusive is the harder one. That's the one where we have probability of A plus the probability of B minus the probability of A and B. Right? YouTube, did you hear that moan? It was delicious. Complaining is great. Okay. Now we have, yep, the chicken is cooking. So since we have these numbers here, we have our 1/2, we have our 1/8, we have our 1/16. You know, let's just make these numbers have common denominators right away, even before we plug them in, okay? Let's make it before that. So to make 2 become a 16th, what we'd have to do is we'd have to multiply it by 8. So I'm going to multiply that by 8. So it's 8/16. Then to make 8 into a 16th, we have to multiply them by 2, multiply that by 2, so it's 2/16. So to find the probability of a number greater than 4 or an 8. Where? Just, it's multiplication because I'm getting it to be. Okay. So I take my probability of A plus the probability of situation B minus the one that they share. I'm just going to drop straight down here. So I have 8 minus 2 is what? Or sorry, 8 plus 2 is what? Darn it. 10. 10 minus 1 is what? 9 sixteenths. So the probability of being greater than 4 or 8, you have a 9 and 16 chance of getting it. Okay? What would you reduce that by? Three times 5 is 15. Yeah. Yep, you know what? That's a very common mistake. And there you have it. That is compound section. Section 1010 probability. Test Friday. Study session after school tomorrow. Yes. Oops. And that's all she wrote. Let me turn off this.